Hi, in the previous video, I showed you how to create a supercell from the bulk, and with the process we used, it was much more tedious. So we have to build using boundary. We build this, export the file, and then convert it into a VASP format, which seemed a little bit tedious. So here I'm going to describe a much more simple way of getting it done. So I'm going to reverse the boundaries back to the original figures and do this with you. So instead of changing boundaries to 2, 2, 2, I'm taking it back to 1. And then I'll go to edit, edit data, and then transform the unit cell itself to a 2 by 2 by 2 unit cell to create a supercell. Okay, so over here you go to transform and give it 2 by 2 by 2. And that's it. So we click OK, and now we have our supercell directly. And for us to do the doping and everything, we have to go to File and export the data in VASP format, which allows us to dope. So on the desktop, we can export to the desktop as ion p by 2 and save it in. So this is the simple method. Let me add simple to it in VASP format and save it to the desktop. Now we can go to desktop. I prefer the Cartesian coordinates. So we should output the current unit cell and then OK. So hopefully we get the 16 atoms over there and then move on with our lives. So this is our new file structure. We save the unit cell. So it gives us just the 16 atoms and it doesn't give us the periodic unit, which is perfect. So this is the file. You can dope by just introducing a new element and deciding on the position you want to put it. If you want it at the third position, you count 1, 2, 3, and then put ion at position 3, meaning that ion will be the first 2 elements, hydrogen comes, and ion will be the next 11. So it reads based on the position you give it. That means the first 2 should be ion, the next 1 should be hydrogen, the third position should be hydrogen, and the next 11 should be ion. So that's how you are describing it. So the first 2 will be ion, the next 1 will be hydrogen. So out of 16, there should be 13 left to represent the ion. So that's what you do, and then we can save and re-visualize this. Iron is quite a small element, so let's just use the calcium to make it big enough for us to see. Control, save, and we visualize again. Yeah, so that's what you have. And then again, you always have to save the unit cell so that it gets rid of the periodic units.